want to welcome to everyone there to our Success Factors webinar. My name is Carlos Perez, and today's topic is Structural Steel Connections Design Solution. During this webinar, we'll be having a short introduction to RAM connection. Then we will review the complete workflow to design and detail steel connections. In that sense, we will be specifying the design configuration, defining load conditions and load combinations, creating new joints, and assigning connections by the use of templates, basic connection tools, and smart connections tools. Finally, we'll be reviewing reports and detailings. RAM Connection is a software for structural engineers for analysis and design of steel connections. It is available in the standalone mode, which is the version that we'll be using during the webinar, but is also totally integrated with other structural software like STAAD.Pro, RAM Structural System, RAM Elements, and Leap Bridge. The design of steel connections can be done in a short period of time due to its power and simplicity, as you will see. Currently, RAM Connection not only has frame type but also truss type connections. It is also included as part of the Structural Enterprise license. The software is available in English, in Spanish, in Chinese, not only the UI but also the documentation and tutorials. Regarding the specifications, RAM Connection currently includes the AISC specification 2005, 2010, and 2016 for both methods, the ASD and the LRFD. Not only that, but also seismic provisions and pre-qualified connections are included. The Eurocode 3 and its 2005 version with the British National Annex is included. Besides, we have the 2003 version of the Chinese code, the 2000 version of the British standard, the 2007 version of the Indian code, and the 98 version of the Australian standard are available. Very soon we will be releasing the Canadian and New Zealand design codes. On top of that, a complete anchor design and optimization is an exclusive feature, and it's available for almost all design codes. Let's start with the application. The main window of RAM Connection has different work areas. We have the File button in the top left, which opens the backstage that has basic file options, and also it has a list of the recent models where it's possible to see a thumbnail of the connection selected in each of them. Then we have the Quick Access toolbar that contains the most frequently commands used, like new model, open, save, and undo commands. Below we have the ribbon that gathers all the options for creating and editing joints, managing load conditions, and managing all the possible databases like sections, materials, connection templates, bolts, welds, and anchors. In the Design tab, we have all the tools required to assign connections to a given joint. In the Output tab, we have all related to data and result reports. And finally, in the Bentley Cloud Services tab, we have all related to Connection Center, Connect Advisor, and the option to associate or disassociate the model to a given project. At the center we have the graphic area that shows a 3D representation of the joint, the connection, and the members. In the right part we have all related to the joint information that contains, for example, the beams, columns, and braces. There you can check the sections, the materials, and also the connection that has been assigned to the joint. In the bottom part we have the joint list that shows all the joints and connections that has been assigned to the model, where it's easy to select one to review it. In the right part we have all the available connection templates that can be used at any time. Finally, at the bottom we have the status bar that shows important model information, for example the number of elements, the model status, the model current units, and some options of panning and zoom. Let's start modeling connections. Let's open a new model. The first step will be to define the unit systems to work with. In the status bar, select the desired unit system. In this case, we will be working with the English one. Not only the main system can be selected, but also some specific ones if it's this required by the model or the reports. Unit systems can be changed at any time. Then we need to define the load cases that will be used to assign loads. Load cases and load combinations are managed using the Load Conditions Manager. This is found in the Home tab in the Load Conditions group. Let's define two load conditions, one for the dead load and the other for the live load. As you can see, dead load is always created by default when creating a new model. In this case, we only need to add a new one for the live load. In order to do that, we will use the toolbar in the right. In the same dialog, it's also possible to add load combinations. We only need to define an ID for the combination, let's say combination 1, and set the different factors for the load cases. For example, 1.4 for dead load and 1.6 for the live load. You can see in the text editor at the top how the equation has been formed. So this will help you to understand if the load combination that you have set is correct. I will delete this one. It is also possible to generate automatically the load combinations. In the Load Conditions group, press the Generate button. This will show the Generate Load Combinations dialog with different options. In this case, as we will be using the ASC code, let's select the latest ASCE factored load combos. As we have defined only two load conditions, the dialog is prompted as the two correspondent load combinations. We'll accept. Now that the load conditions and load combinations have been defined, we can start modeling the joint. In order to create a joint, we'll go to the Joints group in the Home tab and press New Joint button. A joint is just a junction of different structural members where a connection is required to hold the structural integrity. Brand Connection currently has the ability to create joints for frame type and truss type connections. In frame type, you will find the ability to create beam to column, beam to girder, beam and column splices, vertical bracing connections, horizontal bracing connections, and base plate connections. Let's start with the beam to column flange joint. For a beam to column flange joint, we need to define all the information required for the beam and the column. In this case, we'll define that the beam is just a prismatic member. This means that the beam has a constant depth over its length. We'll use a W14 by 74. And a material of A992. It's also possible to set skew and slope angles, but in this case we'll assume that the beam is complete horizontal. For the column, we will also consider that it's a prismatic member, and we'll define its section as a W16 by 89 and a material of A99/2. Once that all information required for the joint has been defined, then we can start adding loads. As you can see, in the loads tab, you will have the option to define loads for the two load conditions that we have already defined. We'll define 12 kips for dead load and 7.5 kips for live load. In this case, for the first example, we'll be assigning a shear connection. Then we have our joint created, and we can start adding connections to this joint. The first method that we'll use will be the templates method. In order to start with the assignation process, we need to define the standard that we'll be using for the design. In order to do that, we go to the Design tab, and in the Assignment group, we select the code. This will open automatically the customized connection design, where we can select the desired specification. You will see here all the available design codes. In this case, we'll be using the latest AISC code, and also some other options. For example, if you required a maximum stress ratio limit different than 1. In the case of a seismic design, if you want to define one seismic category. And finally, the load conditions used for the design. In this case, all together load conditions and load combinations are selected. I will accept. Okay. Then, before starting assigning connections, we need to define what a basic connection template is. A basic connection template can automatically adjust its geometry to fit connection members, but does not optimize the connection elements like plate and bolts. In other words, a basic connection template is a given set of well-defined connecting elements which are checked against the demand in the selected joint. Let's check the single plate BCF basic connection template. The name of the basic connection template indicates the most important information. For example, the second from the list indicates that it's a template for a single plate for a BCF joint, and it has a 1/2 inch single plate, and it also has 2 bolts of 1 inch diameter. Let's try assigning this connection template to our model joint. In order to do that, we select the desired template and we go to the Assign Template tool in the ribbon bar. You can see that the single plate has been assigned to our model joint. In the thumbnail, you can check that the strain radius is less than 1 for the critical load combination D2. The yellow color of the status indicates that there are some geometrical warnings. Let's try it with a different template. For example, a quartal plate with 3 bolts of 3/4. The connection has been also assigned to our model joint, and you can check that the status of the connection is green and it's okay. Before using the second method, let's create a copy of our model joint to check the differences. The Home tab, I will select the joint that I want to copy from, and then I will create a copy. So this copy has exactly the same members and also the same loads. The second method consists in using the basic connections to assignment buttons. These are located in the Design tab in the assignment group. When using this, the program searches in the list of the basic connection templates until it finds one that works well in the joint for the geometry and loads. Let's try it with a single plate. As you can see, RAM connection has selected a template, which is the one that fits the best for the model joint that we have created. And in this case, it's the same as the one that we selected before. The third method is similar to the second, but instead of searching in a predefined list, the software will assign a smart connection. Smart connection template can automatically optimize the quantity and dimensions of the connection elements, like plate and bolts. As the optimization is performed internally during the design, only one template for each connection type is required. So before using the Smart tool, let's create a copy of our model joint. The Smart tool is also located in the assignment group in the assign bottom, and it's the second one from the list. And we'll assign a Smart single plate. When a smart connection has been assigned, not only the parameters specified in the basic template have been optimized, but also well sizes, bolt diameters, and plate thickness, leading probably to the most efficient connection design. One of the advantages of using a basic or smart tool is that if anything changes in the model joint, like member sections or member forces, the redesign buttons will apply again the basic or smart tool to obtain the connection that fits the best for the modified model joint. For the first two model joints, it is easy to identify the plate thickness, the number of bolts, and the diameters from the basic template name. But for the last one, as we use it as smart, we need to edit the connection to check this. In order to edit the connection, you can double click directly in the graphic area or use the tool that is located in the Design tab in the Connections group called Edit. Connections are edited or created using the connection path or connection dialog. The path is conformed by the following areas. At the top we have the main toolbar that contains the general commands for saving, printing, reports, together with some options to modify the model view. In this zone we have also the traffic light that shows the strain ratio and the general status of the connection. The color green indicates that the connection is okay, the yellow that there are geometric problems, and the red that there might be one or several limit states that have failed during the design. At the center we have the graphical area that shows the 3D or the DXF representation of the connection. In order to switch views, you only need to click in the tabs at the right. That will be the DXF. You can see several views of the connection. Finally, in the left, we have the addition area, which is the panel that is used to show and modify connection data. This panel is organized in three sections. The first will be the general information that contains the design parameters for the connection. The second will be the member section that has all the information related to the members that conform the model joint. And finally we have the connection section that has all the information of the connector that has been assigned to our model joint. Any change in the addition area will impact directly in the 3D view the general status and strain ratio of the connection. For example, let's try changing the bolt diameter for 3/4 to 1 inch. you will see that the 3D view has been updated, and also that the strain ratio has changed, and now the general status of the connection is yellow. In order to check what's causing this, we need to review the design report. The tool to open the report is located in the main toolbar. This is the report window of RAM connection. It's conformed also by a main ribbon toolbar, where it's possible to find very interesting features like export to Excel or Word. The design report is organized in three parts. First, we'll have the demands that are the load using during the design that comes from the member forces entered when conforming the model joint. Then we have the geometric considerations, that are several geometric limits imposed by the code or common practices for different connecting elements. Any failing in this part will cause the connection to be yellow. And finally, we have the design checks that contains all the limit states verified for the connection parts and the joint member. Any failing in this section will cause the connection to be red. In this case, as the connection is yellow, we know that one or more of the geometric checks have failed. If we review this section, we will see that for the shear plate, the horizontal edge distance is not compliant with its minimum value. The design report can also present detailed equations for geometric and design checks, making it easy to identify what's the parameter we need to modify to fix the problem. In order to show the equations, we need to press the View Formulas button, the main toolbar. Equations have been populated, and now we can go again to the horizontal edge distance check, and we'll see that the minimum value depends on the bolt diameter. As we have increased the diameter, then this minimum value have also increased, and now with the value of 1.5 we are not compliant. So we have two options here. We can increase the horizontal edge distance or decrease the bolt diameter. Let's try both. So in order to change the connector dimensions, we'll go to the connector section, and we'll see that in this part we have the horizontal edge distance listed, and we have a current value of 1.5. Let's try it with a value of 2. With 2 inches we are compliant with the minimum value, and therefore our connection status is again green. If for some reason this is not possible, then we need to change the bolt diameter. So let's try with the 7 of 8. It's not enough, we are still in yellow. And if we go back to 3/4, that was the original diameter, we are now green again. Let's try now reducing the single plate thickness, for example to 0.15. As it is expected, this will cause the connection to fail. Let's check the results. Under the design check section, we can see that 2 limit states have failed due to the reduced thickness. Let's show the equations. If we review the shear rupture capacity calculations, we can see that the value depends on the single plate length, the bolt diameter, the plate thickness of course, and the tensile strength of the plate material. Let's try changing some of these. If we want to modify, for example, the single plate length, we need to know which parameters are needed to calculate it. So let's switch to the DXF view. The DXF view shows you the top view, the lateral view, and the front view of the connection. If we review them, we can see that the single plate is described in the lateral view. So let's zoom in. The single plate length is determined by the bolt spacing and also the vertical edge distance. So in order to increase it, we need to change one of these values. So let's try, for example, with the vertical edge distance. In order to identify where this value is displayed in the edition panel, we just need to click in the DXF value. So currently we have 1.5. Let's try it with 3. This casts our single plate to be now 12 inches, but with this length I have a yellow status, probably because the single plate does not fit in the beam web. So let's reduce it a little bit, like 2.5. With 2.5, both geometrical and design checks are okay. Let's try another thing, for example, changing the plate material. Currently we have for the single plate an A36 material, so let's try it with another one that has a larger tensile strength, like an A572 grade 50. Of course, this will cause also our design checks to pass. As you can see, in this way it is very easy to identify what parameters need to be changed and modify the connection to fit our needs. The connection path has other features like export to DXF, which allows the user to export the DXF view at any time to be included in the project drawings. The DXF view can be customized, as the user has the options to turn on or turn off different layers. It is also possible to report all the connection data in case those are needed to be included in design calculations. This report has the basic information regarding the members of the joint and the connector used. The same way, it is possible to work with all other shear connections. Let's check what other options we have in RAM connection. We have the single plate, which not only supports W columns but also hollow sections. We have the flexible end plate. We have the double angle cleats, which can not only be bolted to the beam but also welded. And also we have the option to consider just a single angle. We have the bent plate, which is used for the cases when we have skew with beams. We have the standard T, that, like in the case of the double angles, can be also welded to the beam. We have the stiffened seated connection, and for the seat we can use double angles, like in this case, or T, or a plate. We have also the option of unstiffened seated connection, which can be bolted to the beam or welded. RAM connection is also able to design shear connections for beam and column splices. So we have here the single plate for a beam splice. We have the option of double angles, The same for a column splice, the single plate. And finally we have the end plate for a column splice of hollow sections. In this connection, not only round sections are allowed, but also rectangular ones. RAM connection can also design moment connections. Let's check some examples. First, we have the flange plate. This connection can be assigned to model joints with W column or HSS columns. Next, we have the moment angles, the moment end plate. This connection can be designed following the design guide 4 or the design guide 16, and the end plate can be flush or extended in one way or both. Then we have the directly welded connection. All moment connections for beam to column flange are able to add stiffeners to the column panel zone. In this case, we have full depth transverse stiffeners, which can be also defined as partial or just in one of the flanges. It's also possible to add stiffeners for the column web, like double plates or diagonal stiffeners. Moment end plates can also be assigned to hunched beams. There are also moment connections for beam splices, like in this case a flange plate, or column splices. Moment end plates can be assigned to knee joints, to apex. Beams for this connection can be tapered, prismatic, and hunched, like the one in the example. And finally we have the cap plate, which is used normally at column ends. Let's review now some bracing connections. For the first connection, we have a full column beam brace gasket with HSS sections at the top and the bottom. In this case, sections are different just for illustrative purposes. Let's check the connection path. Members in this connection can be totally customized. For example, there might be the case that we don't have the right beam, so the connection will become now a K connection. Or we can have just the bracing at the bottom, or in the top right quadrant. Braces sections can be changed between channels, I sections, rectangular, round and square hollow sections, single angles, T's and W sections. Also, the connections at the different interface can be customized. In the case of the beam to column connection, we have single plates and angles. The connections for all the gasket interfaces can also be changed. Let's start with the brace to gasket connection. In this case we have the vaulted configuration, where the brace is bolted to the gasket by means of a plate, but it could also be directly welded. The gasket to column or to beam can be changed between a directly welded, like in this case, or could be a single plate or angles. For the second connection we have the chevron configuration. In this case we have W sections as braces connected by claw angles and web plates to the gasket. In this connection we can have also the option to set only the chevron to be at top of the beam or at bottom. Then we have the gasket for the X-brace configuration, having as braces in this case double angles. We have here another example, a K connection having as braces channels, and as support an HSS square section. Next we have an horizontal gasket for the column beam brace configuration. In this case the brace could be customized to be attached to the top or bottom of the gasket. This is another gasket for the horizontal girder beam brace configuration. This gasket is normally used for members that are aligned to the top, so the gasket is directly bolted to the three members. It can be also configured to be connected to the girder and beam webs by means of double angles. And finally we have the horizontal gasket for the X brace configurations, having single angles as braces. Let's check another model. In this model we have several base plate examples. Connection number one is a pin base plate where anchors are located inside the column flanges to allow rotation. Not only W sections are allowed for columns, but also rectangular and round hollow sections. Connection number 4 is a fixed base plate. Let's check the results. Here you can see that the base plate design is performed following the AISC design guide 1, where all checks are included regarding the concrete base, the base plate, and also the column. The report also includes a complete anchor design. This is performed following the ACI Appendix D, where all the checks regarding tensile and shear are included. It is also possible to check the varying stresses under the base plate. Here you can check the varying value and also the varying length. It's also possible to see the tensile forces at the anchors. Here you can see that the anchors inside the bearing length do not have any tensile force. And finally you can check the anchor groups for the tensile and shear breakout. It is also possible to define stiffeners in base plates. We have the option of plates as stiffeners, as you can see in connection number 5, and also channels as stiffeners. Finally, a RAM connection also includes the options to design base plates for column bases in bracing connections. Let's check now a model with some truss connections. Tubular connections are designed following the AISC 36016 Chapter K, together with the Design Guide 25 and the HSS manuals. In this way, it is possible to design Y or T type connections, the K or N type, the cross type, and the KT type. As you can see, not only rectangular or round hollow sections are permitted, but also a combination of them. Let's check connection 5. Something interesting in the design is that, for example, if a given joint, like in this case, can be classified in more than one connection type, the report will show the connection classification, and for each it will show the branches conforming the connection and also the percentage of participation of each of them. For example, branch number 2 that participates in the K and the cross connection has a percentage of participation of 53 for the K and the remaining 47 for the cross connection. We will be giving more attention and details to this in upcoming webinars. Once that we have completed the connection design workflow and shown several connection types and examples, we are finished with the presentation of the Bentley solution for steel connections design. Thank you all for your attendance.